So in this question here, we want to expand and simplify this binomial term here, 3 plus 2x to the power of 5. Now, what we don't want to do is to just simply FOIL this out 5 times. That's going to take us too long. So what if we've got this to the power of 15? We'll be going on and on, will take forever. So we need a technique called binomial expansion. So what we do is we write the general form of this kind of term here as a plus b to the power of n. Now this expression here, our a is the constant 3, so a equals 3. Our b is 2x, and it's a positive 2x, so always take in consideration the operator inside the brackets. So b equals 2x, and the indice is 5, that's our n, so n equals 5. Okay, so what we do is, the general way to write this would be, we have a coefficient which we call coefficient 1. I'm going to show you a nice way to find those in a moment. So coefficient 1, and then we multiply that by a to the power of 0, and then b to the power of n. So in this case it's b to the 5. And then what happens is this will increase by 1 each time, and this will decrease by 1 each time as we go along all of the terms. And then our second term will be a second coefficient, and then multiply that by a to the power of 1 and b to the power of 4. So notice that's increased by 1, that's decreased by 1. And the same again, we find a third coefficient, multiply that by a squared and b cubed. So again, notice these a's are all increasing by 1, the b's are all decreasing by 1. And that will go on and on and on, up until I get to my 6th coefficient. So notice when our n is 5, we will have 6 terms. So there's always n plus 1 terms. So my 6th coefficient, and I multiply that by a to the power of 5 and b to the power of 0. So hence, that's our 6 terms. So now what I'm going to do is, I'm going to write all these out with our a, b and n specific to this question. So first coefficient, before we can go any further, we need to work out what those coefficients are. And the way I use for this term here, when it's just as low as 5, we can use Pascal's triangle. So Pascal's triangle, the setup for that is first you draw 1 and then 2 ones opposite sides of that 1 in a pyramid shape. And then what we do is, each line we go along, we add up the gaps in between the 2 numbers above. So here we just write another 1. In between here, 1 plus 1 is 2, so 2 goes in there, and then a 1 goes on the edge. And the same again for this line. So now we've got a 1, 1 plus 2 is 3, 2 plus 1 again is 3, and another 1 on the end. And what we need now, we need a 5th line along here. So now we've got 1, 4, 6, 4 and 1. And then the last line that we need for this question, 1, 5, 10, 10, 5 and 1. And then you'll notice along here there is 6 numbers. They will correspond to our 6 coefficients that we need. So just writing underneath which one is, that's coefficient 1, coefficient 2, coefficient 3, coefficient 4, coefficient 5 and coefficient 6. Okay, so let's take this Pascal's triangle off the board. I'll write these coefficients up along here, and then we'll continue to expand out our term. Okay, so I've got the coefficients written on the board there. So now let's expand this out and write it all out, each term that we need. And the question says expand and simplify. So hence that's why we need to write out all the terms. So coefficient 1, that's just 1. Multiply that by a to the power of 0. So we've got 3 to the power of 0. And then we've got b to the power of 5. So 2x to the power of 5. So remember, I'm going to write my 2x in brackets because my 2x also has another coefficient, and I need to raise that to the power of 5 as well as I'm going along. My a is just a constant, so then when I raise that, I don't need my brackets on that, so hence that's why I've written it like this. So now my second term, my second coefficient is 5. Multiply that by 3 to the power of 1, and then b to the power of 4, 2x to the power of 4. So let's write that as 2x to the 4. And then here I've got my third coefficient, which is 10. So now I've got 10 times 3 to the power of 2, 2x to the power of 3. Fourth coefficient is 10 times 3 to the power of 3, 2x to the power of 2. So notice all these powers of the 2x's are dropping and my powers to the 3 are increasing. And then my next coefficient is 5. So 5 times 3 to the power of 4 and 2x to the power of 1. And then my last term, which is corresponding here, sixth coefficient is 1. A to the power of 5, so that's 3 to the power of 5 and 2x to the 0. Okay, so now what we need to do now is just go along and simplify each term. Okay, 1 times 3 to the 0. 3 to the 0 is just 1. So I've got 1 times 1 and then 2x to the power of 5. So 1 times 1 times 2x to the 5, or 2 to the power of 5, that's 32. So I've got now 32x to the 5. So here I've got 5 times 3. And then 2x to the 4, 2 to the power of 4 is 16. So now multiply that by 16x to the 4. Same here, 10 times 3 squared. 3 squared is 9. So I've got 10 times 9. And then 2x cubed. So I've got x cubed and 2 cubed, which is, well, 2 cubed is 8. So I multiply that by 8x cubed. This one here, I've now got 3 cubed. So 10 times 27. And then 2x squared is 4x squared. Okay, 5 times 3 to the power of 4. 3 to the power of 4, well 3 squared is 9. So 9 squared is 81. So 5 times 81. And then 2x to the power of 1 is just 2x. And this one here should yield me a constant. 1 times 3 to the 5. Well, if I multiply that by 3, because that's 3 to the 4, that'll give me 243. And 2x to the 0 is just 1 again. So now I've got 1 times 243 times 1. So now to fully simplify this, I just simplify each term as I go along. So 1 times 32, that's my coefficient, and x to the 5. 5 threes are 15. 15 times 16 is 240. And that's x to the 4. 9 tens are 90, times 8 is 720, and x cubed. And then I've got 10 times 27 is 270, 270 times 4 is 1080, and x squared. And 5 times 81 is 405, times 2 is 810, so that's 810x. And then my last one, just 243. So that would be my fully expanded term that we had at the start, simplified. And that's where we can end it.